So we did the roulette example because it's really basic, but now we want to start learning some other methods of finding probabilities, besides just kind of gut instinct. So first method we're going to use is the empirical method. Now empirical is a definition that you may have seen maybe in science class. I just Googled it for you. It's based on or concerned with or verifiable by observation or experience rather than theory and pure logic. So it has to be from observation and experience. In other words, it has to be from real data. So when we see empirical, that means from real data, like that. Okay, so what will that mean? Well, it'll mean you'll be given the data either in the problem, say like in a table, or maybe written up in the words of the problem itself, or you might have to find that data yourself. We'll work on that later. So empirical probability is the relative frequency. So when you find relative frequency in chapter 2, you're essentially finding an empirical probability. So the relative frequency of the event based on the number of observations from the real life repeatable process. In other words, you take the frequency and you divide it by the total number of trials or the total number of observations. Simple as that. And of course, because it's from data, it's going to vary from data set to data set because every time you do the experiment or every time you look at a different sample, it'll be slightly different. Now, the following example will make it all hopefully clear. So the following table shows the deployment of U.S. active duty military and civilian personnel around the world in 2019 by selected regions. Yes, this is real data. However, it does not include those deployed in ongoing operations in Afghanistan, Iraq, and Syria, which one would imagine is where a lot of active duty military are located at this point in time. But nevertheless, we have these numbers for the active duty military personnel. And you can see, you have a huge number in the US and territories. So 1,196,099 and so on. Now remember this notation down here means I want to find the sum. I want to find the total. So I would want to add all these up. Now of course you can do that with a calculator. That's perfectly fine. But wouldn't it be nice if StatCrunch would just do the whole thing for us? Yes, it would. So I have the data set here. So if you go into StatCrunch and you look up U.S. active duty military, you should be able to find this particular data set because it's publicly available. And it is real. I actually have the link to where it comes from as well if you're interested. All right, so we've done this before, but let's do it again because it's a little tricky. So we want to compute from an expression. All right. So I want to build, I'm going to be building the relative frequencies when I do this. So you have to click build and you have to say, okay, I want to round to 4 decimal places. So I'm going to preemptively make that happen. So I'm going to scroll down here. It's in alphabetical order. I'm going to say round to, and then I want to tell it to take the number and I want it to divide that by the sum of the numbers, right? The sum of the numbers will be the bottom of the particular column. And we'll be able to find that value later for the sake of filling it out in the table. And then we want to round it to 4 decimal places because it said to in the instructions. All right, so round to is saying, hey, find this number and divide it by the sum of the numbers, but round it to 4 decimal places for me. Please and thank you. So you say, okay, and then click compute. And there they are. All the probabilities are found for us. Now I didn't find the sum total, which I could have done. So if I go to stat, summary stat, column, and I say on the number column, I want you to find me, and you're looking for the sum. Oh, there it is, the sum. That's what you want to find. N, by the way, because you might think, oh, it's N. It isn't. N is actually how many categories there are. I'll find both of them so you can see the difference. So N is that there's 8 because there's 8 rows. There's 8 different regions. That's all N tells you. So what you're looking for is the sum. The sum is 1,360,923. So you can write that right in your box at the bottom of the table. Let me close this a little bit so you can see. And I definitely don't need that thing open, so I'm going to shut that so we can all see it. All right, so I'm going to write these numbers down. Matter of fact, I'll pause and write them all in. You can do the same. There they all are. Now, of course, if we did this correctly, we should have all of these decimals add up to 1, right? Of course, if I really want to know, I could always go to the summary stat, and choose columns and have it find the sum for that new column that I created, just to check that it in fact equals 1. Oh, see, it added up to 1.0001. That's because of a little bit of rounding error. That's nice to see because that does happen occasionally. So it's nice to know that rounding error can affect you. And don't be worried about that. That's no big deal. That just happened because all of these were rounded in a particular way, and it ended up being just a touch over what we would have expected. All right, now explain why these probabilities are empirical. Well, it's because they're all from real life data. Which is what empirical means, right? From real life observation. Now, which regions are unusual? Well, reminder that we learned what unusual was back in section 3.2 and section 3.4, I believe. Unusual means two things, one of which is not going to be very helpful to us in this chapter. So unusual means more than 2 standard deviations away, right, from the mean. And unusual means less than 0.05 or 5%. That's the one we're going to use because standard deviations doesn't mean anything to us in this context. We don't have a mean, we don't have a standard deviation. So there's nothing to talk about there. So we're going to look for less than 5%. All right. So if we look here, which ones are less than 5%? So remember it's 0.05. So anything with 0 in the front would be less than 5%. Right? This is 0.5%. This is less than 1%. So it's 0.05 that I'm looking at. And even this one, even region 3, because 0.0481 is less than 0.05. So regions 3, 4, 5, 6, 7, and 8 are all unusual. And again, of course, this is because Iraq, Syria, and Afghanistan are taken out of this and not included in this data set. But nevertheless, that's what we have. Right? They all have less than 5% probability. And that's what it takes to be unusual. That's going to be the more useful definition of unusual in chapter 5 in particular, but also chapter 6 and 7.